Okay, so what we have here is question 10 off of section 3-2 practice problems. And it's saying that, okay, if we have this triangle, triangle XYZ, and we have these two lines, x equals -3 that they're calling line N, and x equals 4 that they're calling line P, what happens when we do this combination of reflections to this triangle? So first of all, you can see I drew this separately because this graph here doesn't give me enough space to get all of this information on it. So I had to draw my own graph over here. I plotted triangle XYZ in the same spot that it is here with the corners of the triangle at the same locations that it is over here. And then you can see I put line P here, and then I put line N where it belongs. And I kind of color coded them because I think that makes it a little bit easier to kind of tell what's going to happen. And now we're going to do these two reflections, but remember when we do a composition of motions, we do the second one first. So the first thing that we're going to do is we're going to take this triangle and we're going to reflect it over line P. So we're going to flip it, flip all the parts across line P. Now you can see this triangle kind of straddles line P. So when I reflect it, what's going to happen is each corner is just going to go over to the opposite side of where it's at right now. So I'll draw this one, let's see, let me grab a new color here. I'll draw this first reflection in this purple color. And so X, the point X right here, you can see that it's 2 units directly to the left of my line. So when it gets flipped over, it's going to get flipped over to 2 units to the right. It's actually going to end up where Z is right there. So let me put that point right there. X ends up right there. We'll call that X prime. Z is actually going to get flipped over to where X is, and Y is going to get flipped over to this point right here. So my new triangle, after I reflect this original triangle over line P, looks like this. You can see each point just got flipped to the other side of line P. Y got flipped from where it is to there, Z got flipped from here over there, and then X got flipped over to there. So X and Z almost like just changed places. And that's that first reflection across line P. Now the next thing that we're going to do is reflect now this purple triangle across line N. So it's going to flip over this green line. So let me get a new color here. I'll use kind of this turquoise color here. And I'm going to move starting with, I'll start with Z. And I'll notice that Z would have to go 5 units over to get to this line of reflection. It's 5 units to the right currently, or Z prime is. And so I'm going to take Z prime, and I'm going to move it 5 units actually over to the left. So Z prime will end up being right about here, Z prime prime, since it's now like the second version of what Z was. Now X prime is doing the same thing as flipping over, and actually I think I'm probably going to end up off my graph because, no, I think I could just fit it. I think X prime prime is going to go right there because I noticed that it should be 4 units. There's 4 units between Z prime and X prime. So X prime is flipping 9 units over on the other side of N because it takes 9 units to get from X prime to where line N is. So I'm going to go 9 more units past. So there's X prime prime. And then Y prime is going to move to basically a place directly above Z prime prime. So it's going to be right here. And so now this turquoise triangle is what I get when I do this reflection to the image that this reflection gave us. Right? So we first reflected the blue triangle to give us the purple triangle. Then we took that purple triangle and reflected it across this green line to give us this one. And so the question is, okay, when I do those 2 reflections, when I do 2 reflections over 2 parallel lines, one of the things we learned about is that that can actually just be described as a single translation. If I look at this blue triangle and I look at where it ended up after the 2 reflections over here, this turquoise one, what you should notice is this blue triangle can just be slid over so that it's where this turquoise triangle is. And the question it wants to know is, well, how did we slide it? How many units left or right and how many units up or down did we slide it to move from here over to there? And there's 2 ways you could figure this out. First of all, you could figure it out by literally counting, taking the X and figuring out how many units it moves over to get where X prime prime is, and then just checking that z and y move the same amount over to get where z prime prime and y prime prime is. So let's look there. To get from x to this line, I notice is 5, and then there's 5 more units to get to there, so that would be 10. And then this would be 4 more, so it looks like there's a movement of 14 units left, which would be a negative 14 movement. And let's just double check with y that it does the same thing. So to get from y to, let's say, the y-axis, okay, that's 6. And then I go 4, 8 more, so the 6 plus 8 would be 14. We're moving 14 units over this way for y, and since z is directly below y and z prime prime ends up directly below y prime prime, we know that it's moving 14 units over as well. So that tells me that my movement in the horizontal direction is negative 14, because I'm moving left 14 units. And I'm not moving up or down at all. You can see that all of these points are just literally sliding straight over. They're not moving up or down at all. So that second blank will just be a 0, showing that we're not moving any units vertically. And so that's one way you could have found that answer, negative 14 comma 0, by drawing it all out, looking at it, and saying, okay, here's what ends up happening. Now the shortcut for finding that answer is using one of the ideas that I talked about in the video, which is when I do two reflections across parallel lines, the resulting translation is equal to a movement of double the distance between these lines. So what that's saying is if I look, for instance, at the distance from N to P, these two lines, how far apart they are 7 units apart. All right? They are 7 units apart. And if I think about going from line P to line N, right, because of the order that I do these transformations, I do the second one and then do the first one, that's moving backwards 7, right? I moved backwards 7 units. So if I just take that 7 and I double it, I get 14. Since it's a movement backwards, it's going to be a negative 14. So that would be like the shortcut version of how you could find that answer there.